We will be calculating step number 3. Calculation of SC and AST total. So again, from clause number G 1.2, page 96. We have the formula for calculation of ASC, that is mu minus mu limiting, which is equals to FSC into ASC into D minus D dash. This is the formula, mu and mu limiting, then FSC is the design stress, while AST is the area of the XC max is the limiting value of XU, and then ASC area of compression reinforcement, and D dash is the depth of the compression reinforcement from the compression phase. So therefore from there ASC is equal to mu minus mu limiting divided by FSC minus FCC into D minus D dash. It is equals to mu, you got it here, total mu, so this is mu you got, and mu limiting, that is 328. So here you will get it around 483 minus 328.55 multiplied by 10 to the power 6. Now this value FSC for it depends upon the ratio of D dash by D, and you can just remember it is around 350 Newton per mm square, and this FCC it is actually 0.446 into FCK, and this multiplied by D 630 minus 70. So here you just to remember FSC value, it is around 350 Newton per mm square. For D dash by D is equal to 0.1. You should always keep this ratio, and you can remember this is the value, while FCC which is equals to 0.446 into FC. So if you solve this, you will get ASC, value of ASC which is equals to 807 mm square. And then we have this value of AST2 as per again the same clause which is given in the IS code. In this AST2 equals to ASC FSC by 0.87 FY. And once you calculate AST2, then total AST which is equals to AST1 plus AST2. AST1 we have calculated in the earlier step, and once you calculate that you will get 2 AST. So therefore now AST2 which is equals to ASC into FSC minus FCC divided by 0.87 FY. Now this ASC which we got 807, FSC that is 350 minus 0.446 into 20 divided by 0.87 into 415. So therefore you will get AST2 if you calculate it around 765 mm square. And therefore now AST, that is total AST, will be equals to AST1 plus AST2. AST1 we have already calculated, that is 1810 plus AST2 we got that is 765. So you will get it around 2575 if you just round it up. So this is total AST you got. Earlier we got ASC. So ASC it is the compression reinforcement. This is the total tensile reinforcement. And now we need to just check whether they are satisfying the criteria of minimum and maximum compression and tension reinforcement. So now step number 4. Minimum and maximum reinforcement. So let's say in compression we will first of all calculate so minimum reinforcement first of all we'll get, and minimum reinforcement that is 0.2% of BD this is equals to around 420 square. And in next case we have the maximum reinforcement criteria, that is 4% of P into D. So that is 4% of. So this criteria is already mentioned. So this is the maximum reinforcement, that is in tension, that is 0.04 BD, also compression 0.04 BD. It is on the page number 47, clause 26.5.1.2. This is coming out to be around 8400 square. And you got the total compression reinforcement of around 865. So that is okay. It is in between minimum and maximum. And you can write down this from clause 26.5.1.2, page 47. Similarly, we have for the tension part, so again minimum AST, which is on the same page number 47. You have this 0.85 BD divided by 5. So you got this 0.85 into so you will get it this around 390 square. Similarly, maximum AST, which is same as that of the earlier, that is 4% of BD, that is 8400. And since our AST, they are in the minimum and maximum criteria in between that. Otherwise, if it is less than minimum, you need to provide minimum reinforcement, that is let us say 390 square, and you cannot provide more than 8400 square. So that is the clause says. So the last we will go ahead with the step number 5, that is selection of diameter of bar. So selection of bar diameter. So let us say first of all for ASC, so this we can just assume, let us have provide 225 plus 212.5. So now if you calculate total ASC, so that would be around 2 into pi bar 4 into 20 square plus 2 into pi bar 4 into 12 square. So which is going to be 854 mm square. Similarly for AST we got, or we can provide 425 plus 225, so that your area of steel should be managed. Accordingly you can provide, it does not necessarily whatever provided it should be like that. You can provide as per your choice. This is going to be 2590 mm square. So now at the last you have to draw the cross section of the beam. This is 300 mm and total it is 700 mm. This is your AST and this is your ASC. We have provided the different diameter bar so that our AST and ASC they are optimized, or accordingly we can provide it. So you should also check what is the area of steel you need to provide, so that optimization or economy can be achieved. So here you need to remember, so whatever outer bars are there, they have to be the higher diameter, or the inner one should be lower diameter. AST we have provided in two layers because we have gone for different diameter bar, and that's the reason we have provided it, so that we can say this is the cross section of the beam.